Good evening, everybody. Today is the first LeetCode vlog that I am posting. I want to track my LeetCode progress and my system design progress, and I think this will help me be more accountable. And hopefully you can learn one or two things. So let's get started. So LeetCode 1390. 4 divisors. We're given an integer array of nums. Return the sum of divisors of the integers in that array that have exactly 4 divisors. If there's no such integer in that array, return 0. So in example 1, we're given an array nums, and we see there's 21, 4, and 7, and 21 has 4 divisors, 1, 3, 7, and 21. So what is a divisor of the integer? I'm assuming that divisor means that any number divided by 21, or actually any number where 21 modulo that number would give you a result of 0. For example, 21 modulo 1, 21 modulo 3, 21 modulo 7, and 21 modulo 21 itself. All of these result in a value of 0, showing that there are 4 divisors for 21. So if that's the case, then we would take the sum of the divisors. In this example, it would be 28, 31, 32. That equals to 32. A current total of 32. And then as we look through the other integers in the array, we see 4 has 3 divisors, 1, 2, and 4, and not 4 divisors. So we wouldn't take those group of integers and add them to the sum. And the same with 7. It has 1 and 7 as divisors, not enough, so we get a total of 32. In this example, we see that 21 occurs twice, and therefore we can take the total and add it to itself, 64. And that gives us a little bit of a hint that if we see an integer that we've already taken the sum from, then we could avoid doing those calculations again and simply return the sum that we had previously calculated from the sum of those divisors. And then in this example, we see that none of these integers have 4 divisors, so we return 0. Okay, so the first thing I'm thinking of is that we could iterate through the numbers array, and then we'd have to a brute force solution would be to iterate from 1 to the integer that we're currently on the index of, this being 21. So we would go from 1 to 22, and we would check if 21 modulo the current value that we're on in the loop has a modulo of 0, then that would mean that that is a divisor. For example, say we do a for loop. Well, say we, to write some pseudocode, we could say iterate through nums, loop from the index value from 0 to the index value plus 1 if the index value modulo that index equals to 0, then we could increment some current total by that index. And then we would also need to keep track that it has a total of 4 divisors. So we could say num divisors equals 0. And then when we get to this conditional statement, we could increment the amount of divisors by 1. And then once we reach the end of the loop, we would need to count the amount of divisors that index or that value in the iteration has. And if it has 4 divisors, then we could add the current total to the resulting total. So we can say if the num of divisors equals to 4, then the result plus equals the current total. And then if that's not the case, then we just go to the next value in the array. Another additional option is that we could create a set. Well, in addition to this solution, we create a set to show that actually not a set, a dictionary, where we would show that if we've run into a value that has a number of divisors of 4, we could store the value, currently 21, in that dictionary, and then store the total, the current total, which would be 32. And then, for example, if we run into that value again, such as we see in example 2, if that value is in the dictionary, then we don't need to go through this loop. We can avoid that and then just add the current total. So we can say something like if index value in dictionary result plus equals to the dictionary of the index value. And then we would continue to the next iteration. Otherwise, we'll continue doing these operations. And then if the number of divisors equals to 4, we'll have to set that value in the dictionary to its current total. So we'll say the dictionary of the index value equals to current total. So that's one solution, and that has a time complexity of, I believe, O of n plus m, which is O of n is the number of iterations, or the time it takes to iterate through the nums array, and m is the time it takes to iterate from 1 to the actual index value, which we see in this iteration, or this loop. And the space complexity is O of n for creating the dictionary. So this could be although there is some additional space with creating the dictionary, it would save some time, prevent iterating through, or prevent going through this range for each value. So let me think of another solution. Yeah, that's currently the only thing I'm thinking of. I'm wondering if there's some way I could, or I should, store the, I was gonna say somehow use the range that, or this loop right here going from 0 to the index value plus 1 using, no, I don't have a full thought. I'm kind of getting a little bit mixed up. Okay, this is the solution I'm going to go with. So let me implement that now. So I'll say nums dictionary equals dictionary. Then we'll iterate through the nums. For num in nums, we'll say we need a result equals to 0. And then we will return the result in the end. And then we'll say if num in nums dictionary result plus equals to nums dictionary num, else if it's not in the dictionary, then we'll go through this process. So we'll say num of divisors currently equals to 0, and then we'll say for I in range from 0 to num plus 1, we'll say if the num modulo, and this will actually be from 1 to nums plus 1, if num modulo I equals to 0, num of divisors plus equals to 1. And then we also need a current total equals to 0, cur total plus equals to I. And then at the end we need to check if the number of divisors is 4. Result plus equals to the current total. And then we'll save what that current total is in the nums dictionary so that we don't have to do that operation again. So let me look this over. So we're iterating through the nums. If the nums is already in the dictionary, then we'll just add whatever value is attached to that key, being the num. Else, we have the number of divisors, the current total. We're iterating to the num plus 1. If we get enough divisors, if we get 4 divisors, or excuse me, if the modulo of the num with the index is 0, we increment the divisors and store the current total. And then at the end, if there are 4 total divisors, we add the current total to the result. And then we store the current total in the nums dictionary. So that looks good. So let me do let me do a quick example, or let me run through a test case. So we'll say, we'll go back here. Okay, so 21. So actually, I didn't need to copy that. So we'll iterate through the nums array. First, 21 is the first element, and 21 is not currently in the dictionary. We'll go through, we'll iterate from 1 to 22, and we'll see that 1, 3, 7, and 21 are the only integers where 22 modulo that integer equals to 0. Sorry, 21 modulo that integer is equal to 0. So for each time it's equal to 0, we increment the number of divisors, which gives us 4 total divisors. And then we keep summing up those values, resulting in a total value of 32, which we return the result at the end. Okay, so let me run this. Well, that's taking a long time, so I'm assuming that either it's hung on some piece of my code, or oh, that's interesting. Unknown network error. Okay, I'm going to copy this just in case, paste it right here, and then come back. Oh, fantastic. Well, let me see here. So since that's offline, I'm just going to see if ChatGPT will confirm or deny my result. For LeetCode, I think it was 1390. Okay, I'll just say for LeetCode question for divisors, how is my code a correct solution? Okay, so pass for correctness, not efficient enough for LeetCode constraints. Oh, and per number, yeah. Okay, so this is a good point. I shouldn't rely on creating a dictionary. A number has exactly 4 divisors if and only if it is p to the third, where p is prime. A number has exactly 4 divisors if and only if it is p to the third, where p is prime. P times q, where p and q are distinct primes. You see, guys, I took up to calculus 3, but I don't remember much of it. Okay, so we have a set. I'm not sure the purpose of this. N to the 0.5 power plus 1. If n modulo 1 equals to 0, add I, and then add the num floor division with I. If the length of the divs is greater than 4, n to the 0.5 power, so 1 plus 1. So n to the 0.5. Let me check out the numbers. The square root of n. Okay, that's fair. I is a divisor. J equals n. Yeah, that makes sense. Okay, I'm feeling some resistance in me where I'm like, gosh, this stinks. I don't know. I don't really understand, but this is part of it. So the square root of n, truncate it, 1 to 6. If n modulo I, okay, I think that makes sense. So I is a valid candidate because n modulo I, and then n floor division I, one and 21. Oh, I see. So if 21 modulo 3, then the inverse would give you 7. So you can assume that that is a divisor. Gotcha. That makes sense. And then you have to do floor division so you don't get, so you don't get a float. Gotcha. That does make sense, actually. That's very interesting. You get I and 18. You get I and the pair divisor. One is always, okay, P, Q, and P times Q. Return the sums of the divs. That's smart. Okay. I is a divisor. J is n for division I. N for division I. That would be the J. That's the I. Okay. Yeah. So I learned quite a bit. I'm going to have to come back to this problem to reinforce this idea of using the square root. But mathematically, yeah, that all makes sense. Okay. Well, thank you all for joining me. I didn't get the problem as optimally as I would have liked, but I learned a bit, and I'm going to come back to this problem. And if you want to join me on the next session, if not, I wish you a happy career. Thank you and take care.